Okay, good morning, my student. Um, Welcome to everybody here um, for our physics session for this week. Okay, so today we are going to talk about the gas laws. Okay, and we are going to discuss the different laws that govern the behavior of gas. Okay, and we have studied in the last chapter that molecules can be in solid or gas or liquid state, and there is some kind of difference between the behavior of solid and gas and liquid molecules. Okay, and if you remember that we have said that solid molecules, the particles are in some kind of crystal, and they behaving in the crystal, and they are organized or ordered. Okay, and the behavior of gas molecules is different from that of solid and liquid gas and liquid molecules. So today we are going to discuss the um, gas law. Okay, and if you remember that we have a kinetic theory of matter, kinetic molecular theory. Okay, and the kinetic molecular theory, it tells us the behavior of particles in the gas. Okay, so the behavior of particles. So for example, the gas have particles of gas behaving, and they have a very no shape, no volume, can take any kind of shape, can take any kind of volume. So this is the behavior of gas. Okay, and for liquid state, particles can take a specific kind of shape. Okay, they have the shape of the container, but they can take specific volume. Okay, and for solid state, particles can take the shape and the specific shape and the specific volume. Okay, this is the kinetic theory of gas. So today we are going to talk about gases. Okay, so what to mean by um, gas? For example, suppose you are going to study two or three parameters. What are the main three parameters you have to recognize about when you study gas? Okay, so the first parameter is pressure. Okay, so the first parameter you have to understand it well is the pressure of the gas. Okay, so the pressure of gas. Okay, so this is the first parameter we have to understand. Okay, the second parameter we have to understand is the temperature of the gas. The third parameter we have to understand about when we study gases is the volume of gas. Okay, so why those are the main three important parts of the gas? Okay, for example, suppose you are going to increase the volume of the gas. Okay, at a constant temperature, the only factor that will differ at this moment is the pressure of the gas. Okay, suppose you are just trying to fix the volume and you are going to change the temperature, so the pressure of gas will differ too. Okay, so this is the those are the three main parts of the any kind of differentiation in that. Okay, so either you are going to change the pressure, the temperature, or the volume of the gas. Okay, so why we can just study many things? For example, I don't care about the weight of the gas, I don't care about the density of the gas. The only thing is I care about mostly is the temperature, the pressure, the volume of the gas. Okay, Yasin?
Sir, how can you change the volume of a gas?
Okay, Yasin. So how can I change the volume of the gas? This is a very, very good question. For example, suppose, Yasin, you have um, something like container here. Okay, you have a container. Okay, and this container, okay, contain some amount of gas. Okay, so you are going just to fix the temperature. Okay, so the temperature is constant at this moment. Temperature is constant. Okay, so nothing will affect the temperature of the gas. So the gas will keep the same kind of temperature, and it's isolated from the environment. So you have guarantee that nothing will flow from or flow inside your gas. Okay. So, but you are going here, yes, and to change the pressure of the gas. So what will happen when you are going to change the pressure of the gas? Means you are going to compress the gas, means you are going to increase the amount of pressure upon this gas, or you are going to decrease the pressure on this gas. Okay, so what will happen to the volume? Actually, as I told you, temperature is constant, so T is constant, so D will not play any role in this process, because as I told you from the beginning, T is constant. Okay, so when you are going to increase the pressure or decrease the pressure, what will happen to the volume? Okay, so either the volume will increase or decrease. How? Just let us suppose you are going to increase the pressure. So means you are going to press the gas to lower level. Means you are going to decrease the volume of the gas. Okay, means if this is the volume of gas before pressing, this will be the volume of the gas after pressing. Okay, means you are going to change the volume by decreasing it. Okay, so just try to imagine, yes, and the opposite situation. Okay, you are going to decrease the pressure, so the volume is going to increase, so the volume of the gas is going to expand. So here will be the volume in the second state. Okay, means V3 now is bigger than V1, the original volume. This means that you have increased your volume. Okay, so this means you have decreased your pressure. So this is the first thing. Increasing the temperature, sorry, the pressure will affect the temperature, the volume of the gas. Okay, at constant temperature. Okay, just try to think about this. Imagine we are going to in another situation. So we are going to just play another thing with this gas now. We are going to do something else. Okay, we are going to fix we are going to fix the pressure of the gas, so P is constant. Okay, and we are going just to do something. Okay, so here I'm going to change the temperature of the gas, so it means I'm going to put this gas under the effective oven. Okay, I'm going to heat this gas or decrease or increase the temperature of this gas. So what will happen to the volume? Okay, so imagine you are increasing the temperature of the gas. What do you think? What do you expect that the behavior of the gas will change? Do you think that the gas will expand or the gas will shrink? Like I'm looking forward to your answers. Okay, just tell me your answers. If you can tell me the answer, it will be very, very good. Just try to think what will happen to the gas when you are going to increase the temperature of the gas. Okay, I can see some people are raising their hands right now. Hashim, Hashim.
Yes, Mr.
Yes.
Mr. If you increase the volume, if you increase the temperature, the volume will decrease, right?
If you increase the volume. No, we
If
are
you in-
talking about increase the temperature, not the volume. Okay.
okay,
The
if
main
you
factor,
increase,
listen,
yeah.
Hash. The main factor you are going to affect the gas is the temperature. As long as you are going to change the temperature, okay, the volume will change so far. Okay, so this is actually you are going to just vary the amount of temperature, and as a consequence of this behavior, the temperature, the volume of the gas will change. Okay.
So, Mr. Volume is inversely proportional to temperature or not?
No, directly proportional. Okay, so means when you are going to change.
Mr. How directly proportional, Mr.?
Okay, okay, I will explain now.
Mr. In the book, it's written inversely proportional.
No, you are talking about volume and temperature, not volume
Yeah,
and
yeah, I'm
pressure.
talking.
Okay, okay,
Oh, yeah, okay, okay.
okay.
So volume and pressure is directly. I mean, volume and temperature is directly
Okay, just
proportional.
okay. Uh, Hashim, instead of just thinking about what is already written in book, just try to think in a common sense about this. Okay, this is something you can do in a normal for a normal gas, just to increase the temperature and try to watch, try to observe what will happen to the volume of this gas. So imagine, Yazan, Hashim, imagine you are going to increase the temperature. Okay, so that the number of of collision between the particles of the gas will increase. So the amount of movement the gas will acquire a high degree of movement. It will move more and more and more. It will move faster. So the gas will expand. Means the gas will increase. The gas will increase its volume. Okay, means we are going to increase the temperature. Okay, the gas will expand. Okay, so what will happen in the other case? Think about this. You are going to decrease the temperature, so the temperature is going to be decrease. Okay, so what will happen to the volume? What will happen to the volume of the gas when you decrease the temperature? Okay, so the gas will shrink, will just start to, the volume will start to decrease. So this explains that the temperature and volume are directly proportional with each other. Okay, so but don't forget, okay, you can't change at this moment, right now, you can't change the three factor simultaneously. Okay, you have to change two of them and fix the third. Okay, so either you are going to just fix the temperature, pressure, or volume, but you can't just try to measure the difference in them at the same time, at the same instance. Okay, no, you have just to measure two of them at this instance, and just try to fix the third. Okay, so measure two of them and just try to fix the third. Why this is so important about gases? Why we can't do this? Like try uh, to differ or try to change the three parameters at the same time, because the behavior of gas is completely different from the behavior of liquid and solid. Because, for example, look at solids. Okay, solid material has, or solid material has a specific volume, has a specific um, shape. The intermolecular distance between the particles are very small. The connection, or the connection between particles are very huge, gigantic in this way, like the power connecting the particles with each other. So means particles in the solid state are fixed. Okay, you can just change them in the same way. But when we talk about gas, particles are far from each other. Okay, so you are going to change temperature. Okay, so you can only try to measure either the pressure or the volume. Okay, you are going to fix the volume. Either you are going to change to measure the pressure of the gas or temperature. Okay, so just you are going to play with them in this way. Fix one of them and measure the two other parameters. Okay, so first of all, okay, why I want to give you a clear idea about what we mean by pressure. Okay, so we started to talk about the gases law and something like that, but we didn't study the pressure. Okay, so the pressure so the pressure of the gas, the pressure of anything, okay, is equal to the force over area. Means the force on unit area means the force applied in certain area. For example, if you have force of force equal to 100 Newton, okay, and you have area equal to 5 meter square, okay, so the pressure of the gas will equal to 100 over 5, and this will equal to 20 Newton over meter square. Okay, so this is the what we mean by pressure. So pressure is the force over unit area. Okay, so the force applied on unit area. So this is the definition for pressure. Okay, so the unit of pressure, as you may now recognize, is the Newton over meter square. Means you have here the force, and the unit of force, as you may remember, is Newton, and the unit of area is in meter square. So this give us that the total unit of the pressure is Newton over meter square. Okay, this is the unit for pressure. Okay, so another thing we have to understand that the pressure can be measured in another unit. Okay, so the pressure can be measured in Pascal. Okay, so instead of just calculating the pressure, okay, so instead of just calculating the pressure by Newton over meter square, okay, we can calculate the pressure in another unit. Okay, we call that pressure equal to Newton over meter square, which is equal to Pascal. Okay, so this is another unit for the pressure. Okay, so either you are going to use this unit or that unit. Okay, so both of them are equally representing the pressure. Okay, so those are two units, we are using them to measure the pressure, and they are equal. Okay, so when I'm talking about Pascal, in the same way I'm talking about Newton over meter square, those are equally measuring the pressure. Okay, so this is about pressure. Okay, so as I told you, pressure is the force over unit area. Okay, and the unit of pressure is Newton over meter square. Okay, which is Pascal. Okay, so this is the unit, two units of pressure. Okay, and you remember that volume is measured in either meter square, meter cubic, sorry, or liter, or in centimeter cubic. Okay, those all are different units that we are using to represent the volume. Okay, so and you understand, you have studied that temperature can be measured in Celsius and Fahrenheit, but today maybe in the next session we are going to introduce a new kind of unit or a new kind of measurement for temperature, okay, which is will be the most important thing for us to use to understand the temperature for session to comes, okay. So we are going to use for the next sessions, specifically when we talk about the the temperature of gas, we are going to deal with Kelvin, okay. But just keep this for this moment, okay. So now you understand the unit for pressure, the unit for volume. How can we find the volume? How can we find the pressure? So now Ahmed,
Yes, miss.
yes, do you have any
Oh,
question?
we are on page 76, right?
Yeah, we are in the gas law, okay.
Okay.
Okay, Hashim,
Mr.
yes,
Hello, Mr. Can you explain this scala again?
Pascal, okay. Yazan,
Mr. Just can you repeat how to find the pressure? Because I forgot.
okay. Yet,
Yes, mister. Can you say to me how to find the volume?
okay. Um, Anybody else has any questions about this? Okay, so I'm going to answer your questions about how to find the pressure of how to find the pressure, the unit we are using for pressure, and actually there is a chapter we are going to study, okay, about pressure, but we didn't cover this up to this moment, so we will cover this for the for the next sessions. But up to this moment, what you have to remember, what you have to understand about pressure is pressure is pressure is the force on unit area, means the amount of force you are using to affect the unit area. Means if you have how many force is subjected to certain kind of area, how many force you are going to use it to on certain area, okay. So this is a definition of pressure, and from the definition we can just understand the mathematical equation to describe the pressure. So from this kind of definition you can understand that pressure equals to force over area. So means you have force in the numerator and you have area in the denominator, and this is the basic definition for the pressure. So you have force over area, and you remember that force is measured by Newton, okay, as you have studied in the first term, and you remember also that area is measured by in meter square. So this means you have Newton over meter square. Okay. So now this is the official unit for to measure the pressure. Okay. But we have for pressure we have another unit. Okay, which we call it Pascal. Okay. So Pascal is equal to, okay, meter Newton over meter square. So when I'm talking about Pascal, in the same way I'm talking about Newton over meter square. So either you are going to describe your answer in Newton over meter square, or you are going to describe your answer based on Pascal. So both of them are equally representing the pressure, and you don't have any problem with anybody using them. But just keep in your mind, sometimes in the problems, okay, sometimes he gives you the pressure in Pascal. So you have to understood to be fully understand this, that Pascal is the same unit that we are using to describe the pressure. Okay, so either you are going to describe pressure in Pascal or Newton over meter square. Both of them are equally um, representing the pressure, as I told you. Okay, so we don't have any problem. Okay, but okay, when it comes to pressure, you have to understand that, like, for example, because this physical quantity, the pressure is so important for us. So we are using two kind of units to describe this. Okay, Pascal is a unit, and Pascal actually is it goes to a scientist by the name of Blaise Pascal. He described this unit. Okay, he worked in pressure very much, and uh, he has a unit named after him. So we call this as a Pascal. Thanks for his effort uh, to do some kind of research in the pressure. Okay, so for this reason we are using this as a unit. Okay, okay, Yazan, you have asked it. I don't know, Yazan or yet he asked it about how to find the volume. The volume is very easy. Okay, for example, if you have in your room now, you have 3 dimensions. You can describe your room in 3 dimensions. Okay, either the length of your room, so the length, okay, or the width, or the height. Okay, so you have 3 things to describe about your room: the height of your room, the length of your room, the width of your room, and the multiplication of the 3 parameters together gives you the idea of volume. So volume, and for this reason we are measuring volume in meter cubic, because this is can be measured in meter, this is can be measured in meter too, this is can be measured in meter. So you have meter multiplied by meter multiplied by meter 3 times. So this gives you the idea of, or the value of the volume, which is equal to meter cubic. Okay, or liter, or sometimes some people are using centimeter cubic for to describe very small volumes. So it's something, and the volume will be different from one shape to another. For example, suppose you are talking about spherical shapes. We know how to find the volume of the spherical shapes. Suppose you are talking about the volume of for example, rectangle, or a square, or a cubic, or a cube. So that the volume of it depends on the shape, the geometrical shape that you are describing. Okay, so this is about um, how to describe volume, or how to find the value of the volume. So anybody has any questions regarding anything we have studied up to this moment? If you have any questions left we didn't answer, just raise your hand. Okay, this is very good. Okay, this is encouraging. So now, as I told you, okay, so as I told you, the pressure of the gas, okay, is measured in Newton over meter square, or Pascal. Okay, and the volume is measured in meter cubic or centimeter cubic. Okay, and so the first thing we have to study, or we have to understand, is the relationship between, or the first law. We are going now to just give us the rest of our time to understand the first law of the gas. Okay, so the first law of gases we have is the first law we are going to study for the rest of this session is about The first law we are going to study is the Boyle's law. So Boyle's law. Boyle's law is named after a British scientist. His name is Robert Boyle. Okay, so and he deduced this law. Okay, so the Boyle's law is the law that we use it to describe the pressure, the relation between the pressure of the gas and the volume of the gas. Okay, so you have a relation between volume and pressure, and you may understand now what we are going to do with temperature. I can hear you now, so you can tell me the temperature is fixed, temperature is constant, temperature is not going to change. So because I told you from the beginning, for gases you are going just to change two parameters and fix the third. You are not going to change the three parameters simultaneously. Okay, so you are going just to change two of them and fix the third. Okay, so for Boyle's law we are going to change the pressure of gas and try to watch or find what will be the volume at this moment. So we are going to change the pressure and watch what will happen to the volume, or we are going to watch to change the volume and see what will happen to the pressure. Okay, but you have to understand that the temperature in this moment in Boyle's law is constant. Okay, so this is the Boyle's law. And how can we find the relation between them? So as I told you, imagine you have a container, okay, and this container contain certain amount of gas, okay, and you are going to increase the pressure. Okay, so you are going to increase the pressure means you are going to press this gas. So means you are going to affect with a certain force above this gas. So means you are going to decrease the volume of the gas. So means when you are increasing the pressure increased, volume will decrease. Why volume will decrease? Because when you increase the amount of pressure, okay, the volume of the gas will shrink. Means the volume will change and become lower than it was before. Okay, and this is the connection between pressure and volume. And you can describe now the kind of relationship between pressure and volume in Boyle's law. Means when you are going to increase the pressure, the volume is going to decrease. Means pressure and volume pressure and volume pressure and volume are inversely proportional with each other. Means when you are going to increase the pressure, the volume will decrease. Okay, how can I just remove this kind of proportionality constant? I can just try to do this by writing equality. Means pressure will equal to constant over volume. Okay, over V. Just keep it as V. Okay, so I have here B equal constant over V. I can just try to write this in other way. So I'm going to write this in B multiplied by V equal constant. Okay, so means B multiplied by V equal constant. And this is the basic rule for Boyle's law. Okay, so B multiplied by V equal constant. Okay, so I can just try to imagine this. Okay, imagine you have two systems. Okay, and two systems are exchanging the pressure and volume with each other. Okay, so when you are going to increase the volume of when you are going to increase the pressure of the first gas, the volume of the first gas will decrease. And we are going to decrease the pressure over the first gas, the volume of the second gas, sorry, is going to increase. So I can just try to represent this in another way. I can write this in another kind of representation. I can write this B multiplied B1 multiplied by V1 equal to V2 multiplied by V2. And this will describe the kind of effect, okay, in the two kind of gas. So you have gas, okay, and this gas has P1, V1, okay, B2, V2, and the amount of increase, okay, in the pressure of the first gas will be translated into decrease in the pressure, and the amount of increase in the volume of the second gas will be translated into the decrease in the pressure of the second gas. This is the relation that we are going to use to solve the problems. For example, I gave it to you a problem. Okay, so you are going to substitute to the value for the pressure, volume, or for pressure and volume for the first gas, pressure and volume for this or the volume for the second gas, and you will have three knowns and only one unknown. Okay, so you will have B1, V1, B2, and I will ask you, for example, to find V2, or I will give you B1, V1, V2, and I will ask you about B2. So whenever you find this kind of problem like that, you already have been given three parameters, and I asked you about the fourth one. So you are going to use this, okay? But just keep in your mind that we are talking about Boyle's law. We are talking about the relationship between the volume and the pressure, and keep in your mind that just Boyle's law can work only at constant temperature. So Boyle's law can't change at, for example, when you change the volume. Okay, so when you change the temperature. So when you change the temperature, means you are not dealing with Boyle's law. But Boyle's law can only be represented, can only be dealt with just in case you are fixing your temperature. So when you are not fixing your temperature, you are not talking about pressure law, okay? Sorry, or Boyle's law, okay? So, do you have any questions about this? Yahya?
Yes, can you explain what
Yahya?